Factoring trinomials when a is equal to 1. So that polynomial below, right here, ax squared plus bx times, well, plus c, is going to be our base, or our home trinomial, the thing we will always refer back to. And when a is equal to 1, so whenever we don't see a number out here, that means a is equal to 1. And these are pretty straightforward and kind of like a little puzzle like we've talked about in class. But just quickly, let's go over the steps, and then we'll do a few examples of how one of these would work. So step 1, we want to see if there is a GCF between all three terms. Okay, after we have taken out or factored out the GCF, we want to find numbers that multiply to our number c, but then add to be b. So we want to multiply to c and then add to b. Okay. And lastly, we can always check our work by foiling or doing the box method. So let me split the screen here so we can look at our steps as well as the first example. Okay, so a is clearly equal to 1. So we know we are good to go. There is no GCF. None of these have a number in common or a variable in common, so we can begin. Okay, so how we always want to start these is with two sets of parentheses. And we want to think to ourselves, this first term multiplied by the second term has to give me x squared. So I know that can only be x times x. And these numbers here, these second two terms, need to then multiply to 26, but add to 15. So we might want to think to ourselves for a second and even list out the GCF, or the factors of 15. So we have 1, we have 3, we have 5, we have 15. And of 26, we have 1, we have 2, we have 13, and we have 26. So I want to look at which of these would multiply to be 26, but also add to be 15. So really, we only need the factors of 26. So let's box those off, because they are important. So we want to think to ourselves, 2 times 13 is 26. That satisfies C. And over here in step number 2, that multiplies to be C. And 2 times 13 also adds to be 15. Okay, so we know that we can put a 2 and a 13. And I'll tell you, it does not matter the order. I could have put a 13 here and a 2 here. It doesn't matter either way. And since they're both positive, this one's positive and this one's positive, that means both my numbers must be positives. Okay, so now we can always go back and check ourselves. So I'm going to get rid of all this. Let's go back and check ourselves using, you could choose to use the box method or foiling. I like foiling. So let's do that. Let's multiply x times x, gives me x squared. Let's do x times 13, that gives me 13x. Let's do 2 times x, that's 2x, and then 2 times 13, which is plus positive 26. So when I combine all these back together, I get x squared. My 13x and my 2x go together to be 15x, and 26 remains 26. So I can check and see that I'm finishing with what I started with. So another problem where it's not so obvious that a is equal to 1, a problem where we have to factor out the GCF, would be this one right here. So step one is factor out GCF, and we want to think to ourselves, what do each of these terms have in common? So what does 5v squared, negative 30v, and positive 40 have in common? And hopefully we see that they all have a 5 in common. So what we can do then is essentially divide each of these by the GCF, okay, just to help us to remember what goes inside the parentheses here. So when we divide 5v squared by 5, we're left with a v squared. When we divide negative 30v by 5, we're left with a negative 6v. And when I divide 40 by 5, I'm left with positive 8. Okay. And that is our new polynomial, but we cannot miss that these two things are equivalent. Okay, that this, the original polynomial, is no different than this one. We have just changed the form of it by taking out a 5. So our new a is this 1, the invisible 1 right there. All right, our new b is negative 6, and our new c is 8. So we need to think what will multiply to c but add to b. So multiply to positive 8, but then add to negative 6. So I'm thinking, since this is a positive number, but this is a negative number, that this must be a negative times a negative. Because a negative times a negative, we know, is going to be a positive. So let's go ahead and put our negatives there. Okay, and when I add two negatives, I'm going to get a negative answer. So when I multiply negatives, it's a positive. When I add them, it's a negative. So that's the hint that gives it away, that both of these symbols down here are going to be negative. So numbers that multiply to 8 would be 4 and 2. Do they also add up to 6? They do. So I'm going to put a 4 and a 2. And that is the only difference between factoring out a GCF and the previous problem where there was no GCF to factor out. So hopefully that is an easy concept to gather. We just have to remember step 2 over here, multiply to C and also add to B.